All right, last video here. We're going to do parts B, C, D, and E of problem 8-103. And I wanted to put this in its own video because we get into kind of a new concept here at the end with the idea of an arc and a sector. And we kind of did it in part A, and then they further explain it here in B, C, D, and E. And so I thought I would just make one last, hopefully quick video and doing this. The big idea here with arc and with sector is that you want to find the total area or the total circumference and then multiply it by the portion of the circle that you're looking at. And that portion of your circle is always that central angle. So they're going to give you central angles or some angle measurement here. And that portion is always that central angle out of 360 because 360 is our total circle. And say the central angle, like in part B, is 45. Well, 45 out of 360 is just that portion that's going to be remaining. And so you'll see it here as I start working these problems. I always find the total area if I'm looking for sector, and I multiply that by the portion, or I find the total circumference, and I multiply that by the portion of the pizza or the circle, whatever it might be, to find the sector or the arc. And as we work through it, I hope these vocab words make more sense. But let's start with B. All right. And so we have a pizza that has a diameter of 16 inches, which means it has a radius of 8 inches. My 8s are terrible on here, I apologize. And that is how we're going to find the area and the circumference for part B. All right, and so I'll go down. And in part B, the area is mix that up, is pi times r squared. Well, we just said that the r was 8, or the radius is 8 because it's half the diameter. And so you have pi times 8 squared, which gives you 64 pi for the area. All right. Circumference is 2 times pi times the radius, which is 2 times pi times 8, which gives you 16 pi. So I have total area and total circumference. Now, if I'm looking for and saying in part B, what is the area of that slice if the central angle is 45? Well, I take my total area, which is 64 pi, and I multiply it by that section or that portion that we're looking for. And that portion that we're looking for is 45 over 360. All right, it actually kind of goes back to when we were doing the probability lesson of expected value. We always kind of multiplied our expected value by the portion of the circle. Same kind of thing here. We just take our total area, multiply it by the portion that we want to find kind of that sector. All right, this reduces down to 64 pi times 1/8. That 45 over 360 reduces down to 1/8. And that gives me an answer, once I actually multiply that out, of 8 pi. And so when you're talking about hers, which says, what is the area of that slice? Well, it is 8 pi inches squared. Okay? Now, if we're talking about, and that's actually talking about sector, we'll get into that later, but that's talking about a sector. If we're talking about an arc or just the crust, we have to take the total circumference, which is 16 pi. We got to multiply that by the portion, which is 45 out of 360. It reduces down to 16 pi times 1/8, which goes down to just 2 pi inches. Okay, because 1/8 times 16 pi reduces down to 2 pi. And then my inches squared for area and just my inches for circumference or perimeter or crust, whatever they're calling it here. All right. And so that idea is what we're going to carry on to C, D, and E. It's this idea that you take the total area, multiply it by the portion, or you take the total circumference and multiply it by the portion that you're looking for. Part C, it's saying that Sonia noticed that the pizza, or there was only one slice left from the goalie's pizza. This actually brings back from problem A, which was in my last video, so I got to talk about that just quickly. So in problem C, we're using the pizza from A, and that pizza in A had an area of 100 pi, and it had a circumference of 20 pi. So now we know the total area and the total circumference, And now we're just going to switch it up so that we know we're looking for that portion or that sector in that arc. And so it's saying, what is the area of the remaining slice if our central angle is 72? Well, we have our whole area. Our whole area is 100 pi. We're going to multiply that by the portion we want, which is 72 out of 360. And that should, if I calculate this right, give me my area of what's left. I think that this will reduces down to 100 pi times 1/5, which if I multiply that out, I end up getting 20 pi. And I think this is still working with inches. I believe so. Oh, in the first problem, yeah, we're talking inches. So this is still talking about inches. 20 inches squared is the area of that sector, or that piece of pizza. All right. Now we want to find the length of its crust, which is going to work with, instead of area, it's going to work with circumference. And the circumference I said was 20 pi. And so you take 20 pi, multiply it by the 72 out of 360, because that's the portion that we're looking for. This reduces to 20 pi times 1/5, just like the last one did. And then this reduces down to 4 pi, and that's inches because we're talking about crust or the circumference, not inches squared because we're not talking about an area at this point. All right. And so in problems both B and C here, it introduces this idea that we can find just these portions, the slice of pizza, the area of that slice of pizza, or the length of that crust. And again, we'll see this in D and E. The length of the crust is what we call an arc. The area of just a slice is called a sector. And if we're looking for a sector, we take the total area, multiply it by the portion. And if we're looking for an arc, we take the total circumference and multiply it by that same portion. And then here we're going to do D and E. And D and E are a little shorter and a little more straightforward. But we do have to do a little more calculation, I believe. And so if we look at D, it's really introducing this idea of an arc. And they give you a good picture of what the arc is. And it's saying, the question really is asking the length of an arc when you know that the radius is 6 centimeters and it has that central angle of 30. So we know the portion is going to be 30 out of 360, and we know the radius is 6 centimeters. And so what we need to do if we're looking for arc is find that total circumference first. And so if we go to part D here, I make room here for part D, we have to find the total circumference. And so circumference is 2 times pi times the radius. We know that the radius in part D here is 6 centimeters. And so you get 2 times pi times 6, which gives you 12 pi. Okay, so my total circumference is 12 pi. I have to multiply that by the portion that I'm really looking for. And that portion, like I said before, that I'm looking for is really 30 degrees out of the 360. All right, and we get this here. This actually reduces down kind of nicely, so that we get 12 pi. That 30 out of 360 really reduces down to 1/12. And so then when we multiply that together, we are just left with an answer of pi. And I believe this problem is working in what as my centimeters. And so that is pi centimeters as the length of that arc. Same kind of thing that we did in parts B and C. Found the total circumference, multiplied it by the portion. All right, last one is part E. And E is the idea of a sector, not an arc. A sector, again, a good picture of it, is like a slice of pizza. It's not just the crust, it's the entire area of the slice of pizza. And so what we need to do here is we need to find the total area and then multiply it by the portion. We have a radius that's 10 feet, and we know that central angle is 20 degrees, and so that we'll have 20 degrees out of the total 360 degrees as my portion. We just need to figure out what that total area is first. So if I go down to part E here, we got to find area. Area is pi times the radius squared. I still think it's cool that radius squared is an example of area scale factor in an equation. Anyway, we know that this radius for this problem is 10 feet. And so we plug it in and we get pi times 10 squared, which gives me 100 pi feet squared is my total area. Okay, I got to take that total area, 100 pi, and I got to multiply it by that portion, which is 20 out of 360. Sorry for the bad handwriting there. This reduces down kind of nicely as well. This becomes 100 pi being multiplied by 1 over 18. That 20 over 360 just reduces down to 1 over 18. And when I actually multiply it out, I get 100 over 18 times pi, which really I believe reduces down to, I got to use my calculator quick, 100 divided by 18 is really 5.6 pi. And we're talking about area, and we're working with feet, and so it should be 5.6 pi feet squared. All right, so B, C, D, and E here are just examples of arc and sector, and it's just adding another addition to what we were doing early in this lesson. We can find area, we can find circumference, and now we can just find these portions of area and circumference called arc and sector. That is all I got for the classwork. So the last thing I'll have you do is just look at these math notes. We kind of went over them in a previous video. I think video 2 kind of looked at this a little bit. But just important things to highlight here. It does have all the equations. It has the area equation. It has the circumference equation. Talks about how there's 2 different circumference equations, one with radius, one with diameter. That is right here. It talks about what it means to be an arc and what it means to be a sector. So take a look at this here at the end, and I'll leave about, I don't know, some time here so that you can look at it. And then that'll be it for the lesson. Don't forget to do the homework, and I'll try to speed these up in the future.